Ever wondered how your device knows which wireless network to connect to? That's where SSID comes into play. Now you might be thinking, what is SSID? Well, let me break it down for you. SSID stands for Service Set Identifier. Although it sounds rather complex, it essentially refers to the name of a wireless network. Every time you see a list of available Wi-Fi networks on your device, what you're seeing are the SSIDs. SSID is like a unique fingerprint for a wireless network, helping your device distinguish one network from another. This is crucial because in today's world, we're constantly surrounded by a multitude of wireless networks. Whether you're at home, at work, or even in a coffee shop, you're likely within range of multiple networks. Without SSID, your device would be like a lost child in a crowd, unable to find its way. Now imagine you're at a party and you want to introduce yourself. You wouldn't say, "Hi, I'm a human," right? You'd give your name because that's what makes you unique among the sea of people. That's exactly what SSID does for a wireless network. It provides a unique identifier that sets it apart from all the others. An interesting thing about SSID is that it can be changed. Just like you can change your username on a social media platform, the network administrator can change the SSID of a wireless network. This can be useful for various reasons, such as making the network easier to identify or adding a layer of security. But remember, while changing an SSID can make a network easier to identify, it doesn't necessarily make it more secure. There are other measures like encryption and passwords that play a much more significant role in network security. We'll dive into those in our upcoming episodes. So in essence, SSID is the identity of your wireless network that makes it distinguishable in a sea of wireless networks. Now that you know what an SSID is, it's time to dive a little deeper. The Service Set Identifier, or SSID, is more than just a name. It's the identity of a wireless network, and it plays a crucial role in how devices connect and communicate over a wireless LAN. First, let's understand the nature of the SSID. It's case-sensitive and can contain up to 32 alphanumeric characters. This means that TechSpectrumPro and TechSpectrumPro are considered two different networks. So, if you're having trouble connecting, one of the first things to check is whether you've got the case right. Now, an interesting thing about SSIDs is that they're broadcasted by a wireless network. This broadcasting allows devices to discover and connect to the network, but did you know that an SSID can also be hidden? That's right. For security purposes, you can choose to stop broadcasting the SSID. While this doesn't make your network invisible to determined hackers, it does provide an additional layer of security by keeping it hidden from casual Wi-Fi scanners. But why is it important to have a unique SSID? Well, imagine you're in a neighborhood with multiple wireless networks. If they all have common SSIDs like home network or wireless, it becomes difficult for devices to identify and connect to the right one. It's like trying to find your house in a street where all houses look identical. Having a unique SSID is like having a unique house number. It makes your network stand out and easy to identify. Moreover, having a unique SSID also adds a layer of security. It minimizes the risk of your network being mistaken for a different network with the same SSID, a common trick used by hackers. So, a unique SSID is not just about convenience, it's also about security. In conclusion, the SSID is a critical component of a wireless network. It's more than just a name, it's an identifier, a beacon, and a shield. A unique SSID is not just a name, it's a first line of defense in network security. Now let's shift gears and talk about how these wireless signals are transmitted. Ever heard of RF? RF stands for radio frequency, an essential term in the world of wireless networking. It's a type of electromagnetic wave that wireless networks utilize to communicate. You can think of it as the invisible highway that data travels on to reach your devices. Now you might be wondering, where else is RF used? The answer is practically everywhere. From the Wi-Fi that connects our devices to the internet, the Bluetooth that syncs our smartwatches with our phones, to the radio and television broadcasts we tune into, RF signals are omnipresent. RF isn't just limited to our daily tech gadgets. In a broader perspective, it's significantly used in various fields like astronomy, medicine, and even the military. For instance, astronomers use RF waves to study celestial bodies, while medical professionals use it in MRI scans. Going back to our main focus in wireless networks, the RF waves carry the information from one device to another. When we talk about a network's range, speed, and strength, we're essentially talking about the RF characteristics. RF waves come in different frequencies, each with its own set of properties. Lower frequencies can travel longer distances but carry less data. On the other hand, higher frequencies can carry more data but cannot travel as far. This is why your Wi-Fi signal might be stronger near your router but weaker when you move away from it. In a nutshell, RF is the invisible force that makes all wireless communication possible. It's like the air we breathe, unseen but vital. Without it, the world as we know it, filled with instant communication and information at our fingertips, would cease to exist. So, next time you're streaming a video on your phone or making a call on your cordless phone, remember it's all thanks to the power of RF. RF is the invisible force that makes wireless communication possible. Understanding RF fundamentals can help you grasp how wireless communication works on a deeper level. Let's dive right in. Radio frequency, or RF, refers to the electromagnetic wave frequencies that fall in the range where radio communications are possible. RF signals are an essential part of wireless communication, carrying the information we send and receive over the airwaves. Now, there are two basic properties of RF signals you need to know: frequency and wavelength. The frequency of an RF signal describes the number of cycles the wave completes in 1 second. This is measured in hertz. The wavelength, on the other hand, is the physical distance a wave travels in one cycle and is measured in meters. Here's something interesting. Different RF frequencies are used for different purposes in wireless communication. For instance, lower frequencies, like those in the very high frequency or VHF range, are great for long-distance communication. They can penetrate obstacles and cover large areas. Higher frequencies, such as ultra-high frequency or UHF, provide more bandwidth, making them ideal for data-intensive applications like streaming video. Now let's touch on a critical aspect of RF communications: interference. RF interference occurs when unwanted RF signals disrupt your network's communication. This can be caused by anything that emits RF energy, like microwaves, cordless phones, or even other wireless networks. Interference can result in slower network speeds, dropped connections, and overall poor network performance. So, how do we deal with interference? Well, there are several strategies, like choosing the right channel for your network, adjusting the power levels of your wireless devices, or even physically relocating your devices to minimize the impact of interference. Mastering RF fundamentals can give you a new perspective on how your wireless devices communicate. It's a fascinating world of invisible waves carrying our voice, text, and video from one device to another. And understanding it can make you a better network engineer or just a more knowledgeable user. Well, we've covered a lot of ground today, haven't we? We started our journey by understanding the concept of SSID, which stands for Service Set Identifier. It's that unique ID that differentiates one wireless network from another. We discussed how it's broadcasted by a wireless router to announce its presence to wireless devices. Remember, understanding SSID is crucial, as it serves as the first line of defense in securing a wireless network. We then took a deeper dive into SSID, discussing its configuration and the importance of changing the default SSID to enhance network security. We also touched upon how hiding the SSID can add an extra layer of security, even though it's not a foolproof method. Moving on, we introduced the fascinating world of RF, or radio frequency fundamentals. We learned that RF is the cornerstone of wireless communication. It's the range of frequencies within the electromagnetic spectrum associated with radio wave propagation. This concept is vital, as it forms the basis of how data is transmitted wirelessly. We then went ahead to understand RF fundamentals better. We explored how RF is used in wireless networks, the importance of the right frequency band selection, and how different factors can affect RF signal strength and quality. This understanding is pivotal for anyone interested in wireless networking or network engineering, as it can help you troubleshoot and optimize wireless networks more effectively. To sum up, SSID and RF fundamentals are two key concepts in the realm of wireless networking. They are essential to comprehend whether you're a network engineer, a wireless enthusiast, or someone curious about how wireless communication works. Remember, a strong foundation in SSID and RF fundamentals can set you up for success in the world of wireless networking. Until next time, keep learning and exploring.